Hi students, my name is Engineer Zishan Akbar Mahar. Today I am presenting some basics of civil engineering part 1 from Civil Engineering Excellence Academy. So before starting my video, I would like to request all of you to please subscribe my channel and press the bell icon so that you can get notifications on time. So let's start the video. This video is about the basic concepts of civil engineering. First of all, I would like to introduce my lecture because there are various concepts in civil engineering about which various students and professionals have misconceptions. Misconceptions means they don't know the exactly values or some proportions or some concepts about various things in civil engineering. So, in this video lecture, I will clear out all the misconceptions which are relevant to civil engineering uh, normal or daily life problems. This video presentation is aimed at addressing such misconceptions that many students and professionals don't know exactly. Every concept is described in detail so that you can get everything clearly. So the first content of my video is about cement properties. There are just two to three problems which pertains in civil engineering material, that is cement. So I will start with the very basic thing that every one of us knows and some of us don't know, that normally this is not a universal value, that but normally the one bag of cement has a weight of 50 kgs. Other bag In some countries, the normal weight or available weight of one cement bag is 40 kgs. In some countries, that is 30 kgs. In some countries, that may be 25, 20, 10, or even there are some countries in which 1 kg bags of cement are also available. So, in normally, as I am in Pakistan, so normally here in Pakistan or in Asia mostly, the weight of one bag of cement is 50 kgs. So the next thing which many of us don't know is so you can see in the figure that over here it is written as net weight of the cement bag is 50 kg. This is cement type in Pakistan, DG cement. And next one, this is a general purpose cement. Its weight is also written as 50 kg. Next thing for in cement properties is that the density of cement. The density of the cement which is present in a 50 kg bag is normally as 1440 kg in 1 meter cube. It means, what does it mean? This density means that if we need 1 meter cube of cement, if we need 1 meter cube volume of the cement, then we will have to arrange 1440 kgs of cement, which equals approximately 28.8 or 29 bags of the cement. So be clear about the density of the cement, that in kg per meter cube, the density of cement is this one, 1440 kg. This is not in lb per fit cube or kg per fit cube. Don't um intermix the density. So this density is only given in kg per meter cube. So I will move towards finding the volume of one bag, because as we studied that in 1 meter cube volume of cement there are 28.8 bags or approximately 29 bags. But we must know that how much the one bag of cement contains, that how much volume is available if we have one bag of cement. Then simply we can calculate using this density and weight of one bag of cement, that is 50 kgs. So the volume of one bag of cement in meter cube, this point number 3 is a calculating the volume of one bag of cement in meter cube. That is, as all of us knows, that density is equal to mass over volume. Mass, when divided by volume, gives us the density. This is not unit weight, this is density. Simply, if we show them by symbols, density is represented by rho, mass represented by small m, and volume by capital V. The density of cement in kg per meter cube is this one, 1440 kg per meter cube. Mass of one bag of cement, because we are calculating the volume of one bag, so we will put the mass of one bag of cement, that is 50 kg. And we want to know the volume of one bag. So how can we calculate the volume? We will rearrange this equation. We will take this volume to other side, this side, and we will transfer this 1440 kg to the position of volume. So this is called rearranging the equation. When we rearrange the equations, this becomes something like this. Volume is equal to 50 kg divided by 1440 kg per meter cube. This kg will be cancelled with this, and net answer will be equal to 0.0347. It means that if we have one bag of cement, then its volume will be equal to 0.0347. If you need 100 bags of cement, then their volume will be 3.47 meter cube. So volume of one bag is 0.0347 meter cube, while volume of 100 bags of cement will be equal to 3.47 meter cube. So this was all about the density of cement in kg per meter cube and its volume for one bag when the density of cement is 1440 kg per meter cube. But now moving towards the units of kg per feet cube or lb per feet cube, I am writing here as kg per feet cube because we know the mass of cement bag in 50 kgs. So to avoid the confusion between lbs and kgs, keep in mind that this density of cement is in kg per feet cube. Simply, what does this mean? This means that if we need 1 feet cube volume of cement, then we will have to arrange 41 kgs. This 40.77 means 1 feet cube of cement requires 40.77, means approximately 41 kgs of cement, which is less than one bag of cement, because one bag of cement contains 50 kgs. So 41 kgs mean less than one bag. You can take it as approximately 80%, 0.8 bags. So the volume of one bag means 50 kg bag of cement in fit cube is calculated as. How can we calculate this? Same procedure that we did for meter cube calculations, we will do the same procedure here for fit cube calculations. Because we know the density, we know the weight of one bag, mass of one bag, that is 50 kgs. So simply we can calculate the volume of one bag. So density is equal to mass over volume. When we will put the values in this formula, density is given as 40.77, this one, kg per foot cube. Mass of the bag is 50 kgs, and we will need to know the volume, so we will transfer by the same procedure as in the previous step. We will shift volume to this place and 40.77 to volume place. So volume will be equal to 50 kg divided by 40.77 kg per foot cube. This kg will be cancelled to this, and this fit will cube is in the denominator of the denominator, because this is 1 slash division, so this is second, so cube will be appeared in numerator. So the volume of one bag of 50 kg cement is 1.25 feet cube. So keep in mind in the previous slide as well that volume of one bag of 50 kg. So never misinterpret the data that this volume 0.0347 meter cube is the volume of a bag of cement whose mass is 50 kg. This volume will be different for 40 kg bag. This volume will be different for 25 kg bag. This volume will be different for 10 kg bag. So here I am representing the data to calculate. If suppose we have a bag of 40 kg cement, then you will write here as 40. spite of 50 and density will remain same, you will divide 40 by 14,440 and you will get the volume of one bag. So suppose we have here as 25, you will write here 25 kg. So if we have 25 kg bag, then you will replace this 50 by 25 and you will get the volume for a 25 kg cement bag. So keep in mind this concept, that this volume which I am presenting in this slides is for a 50 kg cement bag. Same idea is here, that this 1.25 feet cube of volume is for 50 kg bag of cement, not for any other mass of cement. If you need the volume of one bag for 40 kgs, then you will have to replace this 50 by 40. So don't write without understanding. If someone asks you to tell about the volume of 40 kg bag, you will not tell this thing, because this is the volume of one bag of cement for having mass of 50 kgs. This is a note, simple note, that all of us has to use always these calculations which we studied in last two slides. We always need to know the number of bags required for any construction work. We don't need to know the volume. For basic calculation, we need to know the kgs or volume, and then we calculate number of bags required for any construction work. And these calculations on last two slides may help you to find out the number of bags required for any construction work. So, in last slides, we determine or we discussed, I told you the density of cement, that is 1,440 kg per meter cube and 40.77 kg per foot cube. But here we will see the densities of some other materials, some other civil engineering materials which may be used in construction industry, and they are very important civil engineering materials. Those materials may be cement. For cement, we discussed as 1440 kg per meter cube. See, this is 90 lb per foot cube. This is not kg per foot cube. In last slide, I told in kg per foot cube, and this is in lb per foot cube. So this in lb per foot cube, the density of cement is 90, and in kg per meter cube, the density of cement is 1440 kg per meter cube. For water, the density is 1000 kg per meter cube, and in lb per foot cube, this is simply we can say this as PCF, pounds per foot cube, PCF. And this normally, this property is at 5 degrees centigrade temperature. It means that when water is at 5 degrees centigrade, then its density will be 1000 kg per meter cube, and in lb per foot cube its density will be 62.4. For PCC it is 2400, and in LPCF that is 150. And for RCC, the density is increased from 24 to 2500 kg per meter cube, and in PCF it will be 155. For reinforcing steel or reinforcing bars, which is used in as reinforcement in RCC concrete or in civil engineering, that the density of the reinforcing steel is 7850 kg per meter cubes, which becomes approximately 490 foot cube, lb per foot cube, that is PCF. And for mortar or cement plaster, the density is 2000 kg per meter cube, that approximately equal to 125 PCF. And for bitumen, the density is 1340 kg per meter cube. It means this is equal to 84 PCF. And for glass or fiber used in civil engineering construction, the density is 2500 kg per meter cube, and in PCF it will be equal to 155 or 156 PCF. So keep in mind, these densities are very important, and these are obtained from well-known sources. These are not wrong values or misleading values. You have to take notes from this video or save this video to keep these values. You can take screenshots or any source or any way to save these information, so you can use them in any future calculations. So moving towards next slides, next topic, the strength and mix ratios of various grades of concrete. Before reading the strength and mix ratios, what is important to note? The important things to note is that according to ACI standards, whenever you need compressive strength, all of us, or maximum most of us, are familiar with this term FC prime, that is compressive strength of concrete. But there are two standards. One is ACI standard. So according to ACI standard, whenever you need compressive strength of concrete, means if anyone is working on design of concrete structures and he is following ACI standards, then he will surely need FC prime to calculate simply modulus of elasticity of concrete. And what will be that FC prime? That FC prime means, what does it mean? It means that the compressive strength of concrete cylinders. This thing is important, that whenever you are using ACI standard and you need the FC prime, means you have to test concrete cylinders, not concrete cubes, when after 28 days of curing. So whenever anyone asks you a question that what do you mean by FC prime, the first question comes in mind that either he is asking about according to ACI standards or British standards. If he is asking about ACI standards, then you will tell that FC prime is the compressive strength of concrete cylinders after 28 days of curing. So simply, what are the dimensions of that cylinder, that concrete cylinder whose strength is checked after 28 days of curing according to ACI standards? So ATI standard mentioned that the dimension of the cylinder had two dimension. First one is diameter of the cylinder, and second one is the height of the cylinder. So diameter of the cylinder, which is used in ACI standard testing, is 6 inches or 150 millimeters or 150 centimeter, 15 centimeters. So diameter of the cylinder D will be equal to 6 inches, 150 millimeters or 15 centimeters. The height of the cylinder H will be equal to 12 inches, 1300 millimeter or 30 centimeter. You can see in the figure, this is the cylinder. This is the cylinder. So height of the cylinder is 300 millimeters, mean 12 inches. And diameter of the cylinder is 150 millimeter. It means 6 inches or 50 centimeter, 15 centimeter. So according to ACI standards, whenever you need FC prime, you have to test concrete cylinders after 28 days of curing. You will never test concrete cubes to get ACI strength or FC prime for ACI standard calculations. So the second standard is the British standard BS. For BS standard, whenever you need compressive strength of concrete, it always means, what does it mean? It means the calculation of compressive strength of concrete cubes. So the basic difference in compressive strength of concrete for ACI standards and British standards is that in ACI standards, concrete cylinders are tested after 28 days of curing, and in British standards, concrete cubes are tested after 28 days of curing. A cube is a shape. Suppose this is a shape, we can say this is a cubical shape. So it has three dimensions. So all the three dimensions, this one and this one, are equal. So all the dimension are each of three lengths, mean this length, this length and this length of the cube should be equal to 150 millimeter or 15 centimeter or 6 inches. So in the figure, you can see this dimension as 150, this dimension as 150, and this dimension as 150 millimeters. So keep in mind, I'm again telling that for ACI standards, you have to use concrete cylinders to determine the compressive strength of concrete, and for British standards, you have to use concrete cubes to determine the compressive strength of concrete. But the time interval for testing the cylinders and cubes is same, that is after 28 days of curing of concrete cylinders and concrete cubes. So, what is the basic relation between cube and cylindrical strength? The cylindrical strength is recommended by American standards, as we studied in the last slide, that ACI always recommends to determine the strength Fc prime of the concrete by using the cylindrical strength, by uh, gaining cylindrical compressive strength of cube cylinders in test. And British standard recommends the testing cubes to determine the cubical strength or compressive strength of concrete in lab. So cubical and cylindrical strength are interconvertible by using this formula, and formula suggests that cubical strength is always 1.25 times the cylindrical strength. This means that cylindrical strength is somewhat less as compared to cubical strength. It means that if you prepare a cylinder of 6-inch diameter and 12 inches height, and you prepare a cube of 6-inch by 6 inch by 6 inch, this will give a strength of 125 megapascal. Suppose that the strength of cube will be 125 megapascal after 28 days of curing. Then cylinder will give a strength of 100 megapascal after 28 days of curing. So what will you do to equalize both of these? You will have to multiply the cylindrical strength with 1.25. Means cubical strength is always 1.25 times the cylindrical strength of the concrete samples. So simply, if we want to simplify this statement, and this statement recommends that cylindrical strength is 20% less as compared to cubical strength. So before studying the mixtures or some mixed ratios or concrete grades, you must have to know the relation between cubical strength and cylindrical strength. So I will show you the usage of these cubical strength or cylindrical test or cubical test in next upcoming slides. So let's go to the next slide. That is ACI standards recommend cylindrical samples. I told you that ACI recommends cylindrical sample strength in their literature. So, what is importance of this cylindrical sample strength? ACI recommends, according to ACI design standards, concrete is divided in three categories. Simply, the concrete is divided in three categories. First one is normal grade concrete. Second one is standard concrete grades, and third one is high strength concrete grades. So these three are written separately to know their strength, their mix ratios, and their corresponding properties. So first one is normal concrete grades, number one through number five. The first normal concrete grade is M5. The grade of concrete is M. M means mix. 5 means its strength is in megapascal is 5. So this concrete M5 has a strength of 5 megapascals, 725 psi. The ratio of the proportion of the parts, the cement is 1 part, sand is 5 parts, and aggregate is 10 parts. For 7.5, M means mix. This mix is 1 part cement, 4 parts sand, 8 parts aggregates, and its strength is 7.5 megapascals. Does this strength reflects? These both strengths or all of these strength reflects the 28 days strength of cylindrical samples. Most of us misconcept these things, that the strength of C10, here it is written as M10. We will see in British standard as this as C10, its strength will be as 10 megapascal. So most of us tells that there is no difference between American and British code, because M10 and C10 have same strength. But that is not the idea. The idea is that here the M10 means it will have a strength of 10 megapascals after 28 days of curing for cylindrical samples. This is FC prime of every mix of concrete after 28 days for cylindrical samples or for cylinders of 6-inch diameter and 12 inches height. For M15, the strength will be 15 megapascal and its mix ratio is given as follows. That is 1 part cement, 2 parts sand, and 4 parts aggregate. For M20, 1 part sand, 1.5 parts, 1 part cement, 1.5 part sand, and 3 parts aggregate, and its strength will be 20 megapascals, and this will be equal to 2900 psi. Next grade of concrete is standard concrete grade. The standard concrete grades has also 5 nominations, that is M25 through M45, means this its strength will be 25 megapascals for concrete cylinders, 30, 35 megapascals, 40 megapascals, and 45 megapascals. This M means mix. Here you can see in first case we have one part of cement, we have one part of sand, and we have two parts of aggregate. Its strength in megapascals is 25, its strength in psi is 3625 psi. But for M30 through M45, we don't have any mix proportions for sand, cement, and aggregate, but its strength is 30. It means that you will try out different proportions for cement, sand, and aggregate, and you will get some suitable proportion for that, for which you will get 30 megapascal strength and 4350 psi strength. Then you will design, or you will design the mix. It means that this is in your hands to decide the proportion of our mix for cement, sand, and aggregate ratios. For concrete grades, for standard concrete grades from M30 to M45, you will have to design the mix for your required strength. For M30, you will design a mix which will give you final strength of 30 megapascals. For M35, you will design a mix which will give you the final strength of 35 megapascals. For M40, you will design a mix having a strength of 40 megapascals. And for M45, you will design a mix having 45 megapascals of strength. So next we have high strength concrete grades number 11 through 15, that is M50 through M70. Their strength will be 50, 55 megapascal, 60, 65, and 70. For all of the high strength concrete grades, you will design the mix for every part, cement, sand, and aggregate. And their strength will be corresponding to their second name, that is M. M means mix. You will design the mix, but their strength must be 50. You will design any mix having strength of 50 but not less than 50 megapascals. These strengths are mentioned as minimum strength required. So for M50, if you ever need M50 grade concrete, then you means that you will design a mix whose minimum strength after 28 days cylindrical sample gives you a minimum strength of 50 megapascals. For M55, the cylindrical strength of the samples will be 55 megapascals minimum. For 60, you will have to attain a minimum design strength of 60 megapascals. For M65, you will have to attain 65 megapascals, and for 70 M70 grade, you will have to attain 70 megapascals of minimum strength. So you will have to design as a civil engineer or a design engineer, you will have to design the mix properly so that you can get minimum these strengths of concrete cylinders. So according to British code 8500-2, the cubical strength is recommended to be achieved in their final strength or minimum strength requirements. According to ACI, the concrete is also divided into three categories as according to British code. Concrete is also divided in three categories as in case of ACI codes. Those categories are same: normal concrete grade, standard concrete grade, and high strength concrete grade. But in normal concrete grade, we have only four parts, 1 through 4, that is C10, C15, C20, and C25. For C10, the minimum strength required is 10. For C15, minimum required strength is 15 megapascal. This is 20 megapascals, and this is 25. But in case of all these things, the strength should be obtained from cubical samples of concrete. So for C10, you will have to prepare a mix of concrete by adding 1 part of cement, 3 part of sand, and 6 parts of aggregate, and you will prepare a mixture. You will prepare a cube, 6 by 6 by 6 cubes. You will test them in lab, and if they are giving at least strength of 10 megapascals, then you will name this concrete as C10 grade concrete according to British code. Same for C15, C20, and C25. For standard concrete grades, number 5 through 8, it's C30 to C45 that you have to design the mix to attain minimum strength of 30 megapascals, 35 megapascals, 40 megapascals, 45 megapascals, and their corresponding PSI strength are given in corresponding uh, their respective uh, rows. So the responsibility as a design engineer, you will have to attain 30 megapascals of strength from a concrete cube, which is prepared by designing a mix whose minimum strength is 30 for C30, 35 for C35, 40 for C40, and 45 for C40 standard grade concrete. So in high strength concrete grades, number through 9 through 13, C50 to C70, you will have to design the mix to achieve 50 megapascal for this, 55 megapascal for this, and 60 for this, 65 megapascals for this, and 70 megapascals for this. Keep in mind that these strengths are different from ACI code because these strengths are cubical strengths. These are not cylindrical strength. ACI codes always recommend or write the strength in concrete in the form of concrete cylindrical testings. But ACI codes always recommend the strength to be written in tables in form of in the strength of concrete cubes. If Thank you very much. If you have any questions, any concerns, or any comments about this videos, you can openly come to comment section and you can comment any questions or concerns in the comment sections. Thank you very much for watching my videos. Please uh, spread my videos to your other fellows if you like this. And at last, I would again request to subscribe my channel and press the bell icon so that you can get notifications of my newly uploaded videos.